Hey folks, thanks for watching my video. We're looking at section 3.4 today. So let's set up our notes like this, and this is section, gee, Merry Christmas. This is section 3.4, okay? Section 3.4. All right. So there are two theorems that we're going to use. We're going to use side similarity, and we're going to use side angle similarity. Yesterday we had angle similarity. So let me zoom in on this guy right here for just a second. And I put this picture over here because this would be an angle situation. In construction, they use similarity all the time. And this top floor in this A-frame home, which I did live in an A-frame home one time, it shares that angle at the top with the entire A-frame home. So let me draw in the entire triangle. Okay, so please put these two triangles down in your notes. And the top one right here, see how it's red and blue, right? The blue triangle shares this top angle with the red triangle, right? Now let's mark another pair of angles. This angle here is congruent to this one by corresponding angles. We abbreviated it last year in my class as CORR, but it's corresponding angles, okay? So I would know the top triangle is similar to the bottom or the whole triangle because of angle similarity. Angle similarity. That's a postulate. It's like so basic. Mathematicians said, hey, we got to start somewhere. That's got to be true. And so now we're going to get to theorems. Now I know, the word theorem and postulate, it's not that important really to you, but it is kind of helps us understand the bigger picture. Okay. This is a theorem now, this theorem called side similarity. And you have to have all three sets of sides in the same ratio in order to use this theorem. So that would mean we would need to know all three pairs of side lengths. If you don't see all the side lengths being listed, there's no chance you're going to use side similarity. Okay. Now I want you to get example one from the course. Okay. Now what am I talking about from the course? I'm going to switch over to McGraw-Hill. And when I go to McGraw-Hill, remember there's this slide deck. So first thing you got to do is you got to make sure you're in the right place. And so you go to course and you go to launch presentation. Oh, let me back up for a second. You got to make sure you're in section 4 too of module 3. So when you click on this little, deal over there, you can go to module 3, section 4, and then you launch the presentation. Okay. I like opening up the tray so that I can see all my options. What kind of things do I want to watch or see in order to understand side? Now, in my notes, I told you to go to example one from the course. So example one is walking us through a side situation. But if you want to read a little bit more, some people have said the green slide is pretty useful. Okay. I'm going to open this guy up and I'm going to close down the tray. And I've already done some of this slide for you. So what they're looking for us to do is they're telling us they're going to match up the JL side and the QM side. Now, why did they pick JL? Probably because just on the left, as they read from left to right, they just picked the first side they saw. It happens to be the side that's the medium size length, like 12 is between 8 and 16. It's not important which one you choose first. But now that you've chosen the JL side at 12, you got to match it up with the medium side from this triangle over here. So I'm matching it up with MQ, right? So 12 over 9, and then you reduce the fraction. So what I want you to do is in your notes is put that triangle down. You got 12, 8, 16, right? So let's go over to our notes and let's put down 12, 8, and 16. So I'm going to put a triangle down that kind of looks like the one that I saw over there, 12, 8, and 16. And the other triangle is like this, 6, 9, 12, like this, kind of like 6, 9, and 12. Okay. So 6, 9, and 12. And then what we just did is we went 12 over 9. 12 over 9, that reduces down to, let's see, 3 goes into there 4 times, 3 goes into here 3 times. So that reduces down to 4/3, right? So on the next slide, let's see what they tell us to do. They say LK and MP. Well, here's LK. It happens to be the smallest side. I'm going to match it up with MP up here. So 8 over 6. So I'm going to put down 8 over 6, and that reduces down to, let's see, 2 goes into there 4 times, goes into here 3 times, so that reduces down to 4/3. All right, so let's just try that out so we are getting what we need to get from these notes. So 8 over 6, that reduces down to 4 over 3. You're going to do something like this on the first few problems in homework. I check my answer. Yep, those are all right. Now it wants me to do the largest sides, 12 or 16 and 12. So I'm going to go 16, and I'm just hitting tab to get down to the next box, kind of a little quicker than clicking on with my mouse. And then that reduces down. Let's see, 4 is going to go into here 4 times and 3 times. So I'm going to go 4, 3, check my answer. Yep, all of that's right. So in your notes, I need you to put that all down, right? So you're going to put that third one down here, and you're going to say, look, pair of sides in that ratio, 4:3. Pair of sides in that ratio, 4:3. Pair of sides in that ratio. This is the one I want you to put down, that third example. That means the two triangles are similar to each other, all right? Now, what I need you to do next is you're going to try to figure out side angle side similarity, and you're going to go back over here to the slide deck, right? So I didn't put that in my notes. I need you to put that in your notes. I'm going to hit next, and it kind of says, yes, they are definitely similar. And then I'm going to open the tray up, and I'm going to go over here to extra example 1. And extra example 1 is going to walk us through a side angle side situation. So let me minimize the tray. And very similar to what we did before, you put your ratios in. I need you to put the drawing down in your notes, okay? So here it is, extra example 1. You're going to copy that guy right there, right over here in your notes, okay? And you're going to set up all the work. Now, I want to do one example with you right down here below. So the tricky part about some of these problems is like, well, which theorem am I going to use, or which postulate am I going to use? I have my choices: angle, angle, similarity. I have side angle, side similarity, and I have side, side, side similarity. So the first thing we want to do is make sure the triangles are similar to each other. Well, I don't know all 3 side lengths in this triangle and all 3 side lengths in this triangle. See, there's an X in those spots. So I'm going to cross off side, side, side similarity. It's definitely not that, okay? I do see that I've got a pair of angles here that are equal, and I have a pair of vertical angles right here that are equal to each other. So the two triangles are definitely similar by angle, angle similarity. I don't need to do any more checking. Done. Now I am going to show you a little bit more because, this theorem right here is where you're doing this extra, example number 1. So I'll just show you real quick how to use side angle side. You're going to match up the smaller side with the smaller side. So we've got 4 over 5. Now somebody might say, well, how do you know like this isn't the smaller side over here? And that's a little bit of a dangerous situation, but I do see that 4 is between 2 tick marks and 1 tick mark. 5 is between 2 tick marks and 1 tick mark. So they got to be corresponding sides, right? Well, 4/5 is already reduced. Okay, so I've reduced that one down. Let's check another one. 8 and 10. Okay, so how does 8 over 10 reduce? Oh, that reduces down to 4/5. So check mark, check mark. Is the included angle between the sides I just tested congruent? Yes, it is. I've got my pair of angles, check mark. So it's side angle side as well. Now you don't need to prove it by more than one theorem. I'm just demonstrating what side angle side similarity is all about. Once you know that the two triangles are similar, you take your ratio, your scale factor, 4/5, and you set it equal to the ratio between a couple side lengths you don't know. So I'm going from the triangle on the left to the triangle on the right. So I got to go x plus 6 over 2x plus 6. So x plus 6 over 2x plus 6. And at the beginning of class, we reviewed this proportion idea. How do you solve a proportion? And I know there's some college professors that hate when high school teachers use this idea of cross multiply. But, we got a lot on our minds. And so I'm going to keep saying it. So we're going to cross multiply. So 5 times x plus 6. And I'm going to distribute my 4 through, and I get 8x plus 24. I'm going to distribute my 5 through, and I get 5x plus 30. And now I'm going to subtract 5x from both sides. I'm going a little slower than I feel comfortable, honestly. But somebody pointed out to me, hey, Nelson, walk me through how do you do all this algebra? So hopefully I don't make a mistake. So I get 3x there, and I'm going to subtract 24 from both sides, and I get 6 here. So I got 3x equals 6. Now I divide by 3 on both sides, and I get 2. Okay, so my x is 2, but they're not looking for 2. So I take my 2 and I plug it back into my problem here. So 2 plus 6, WR is 8. And then I plug the 2 right over here. 2 times 2 plus 6. Well, that's 4 plus 6 is 10. All right. Hey, ladies and gentlemen, I hope I made these 2 theorems clear today. We have side, 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 and side, angle, side. You only need one of them, on a problem to show that the triangles are similar. I hope you can finish the homework in class today. Thanks for setting up your notes.